Okay, so 1.4 is about rational expressions, and today we're going to simplify, multiply, and divide, as well as add and subtract rational expressions. And then we're going to simplify what's called complex rational expressions, and those are just fractions within fractions. So we're going to be doing a lot of factoring today, so let's remember those 3 steps. Our first step is always looking for that greatest common factor, the GCF. And then we want to see if there are any special patterns. The sum of cubes, difference of cubes, difference of 2 squares. And then we can always guess and check with FOIL when we have our trinomials. Okay, so we're going to simplify the fractional expression. I'm going to give you some time to factor for A. And then, like I said, some of you are going to remember how to do some of this. All right, so let's see how we did. So the top is the difference of 2 squares. So we have x plus 8 and x minus 8. And then in the denominator, we're starting with x, and x has to multiply to negative 72, has to add to 1x. So that is 9 and 8, positive 9, negative 8. Okay, you can always do a chart to find all of them, but like 8 and 9 is the first thing that comes to my mind with 72, so it's probably similar for some of you. So you don't have to do this, but that your T-chart will give you multiple options. And then what we have here is multiplication and division. So if we do x minus 8 divided by itself, those are going to cancel, make 1, and your final answer is going to be x plus 8 over x plus 9. You can leave your answer just like this. If you want to leave them in parentheses, that would be okay as well. Okay, and then we're going to factor for B. So you have the 4 on the outside, leave it. X squared minus 1. Is that a special pattern? Yes, it's the difference of 2 squares, right? So I have x plus 1 and x minus 1. So let's see what we can simplify there. Okay, so x minus 1 and x minus 1 is going to cancel. And then when you guys are doing your assignment, just like do 1 slash so I can see what's underneath, right? Because I'm going to have to make sure that you factor that correctly. And then you have 4 over 12. So 4 goes into itself once. 4 goes into 12 3 times. So when you go straight across on the top, you're just left with x plus 1. You don't need the parentheses there. You can keep them. And then here, we're going to leave this as 3 times x plus 2. We're going to leave these in what is called factored form. And so when something's in factored form, you want to leave out that GCF here. Okay, and that's actually what we're going to fill in here. We're going to be writing all solutions in factored form. Okay, which means you are going to have to take out the GCF. It should naturally be taken out. Okay, so do not distribute that back. Okay, and then as we move into multiplying and dividing, let's just remind ourselves how we multiply fractions. You are going to multiply straight across. Numerator by numerator, denominator by denominator. Okay, so we're going to be multiplying those straight across. How do you divide them? What do you guys say? Okay, keep, change, flip. Okay, that's the same thing as multiplying by the reciprocal. When I was being taught, they said skip, flip, and multiply. Okay, so whichever one of those you use is great. Okay, so we're going to perform the multiplication or division and simplify. So the very first thing we're going to do for these is we are going to factor. So I'm going to give you some time here to factor. Okay, I want you to try the first several of those. The best thing you can do for yourself is try this on your own. That helps you get ready for your assessments. All right, it looks like we're feeling pretty good about the factoring. And if there's no GCF, if you have a trinomial, you can always do your guess and your check. So we should have x plus 6 and x minus 2, 6 and negative 2 multiplied to negative 12, and then add to 4. On the bottom, this is a special pattern, so you could write it out as x plus 4 times x plus 4 or x plus 4 squared. Either way is fine. And then don't forget for this one, you have to take out the GCF, the 2. Okay. And even though this is not in like parentheses, you don't see it like that, it really is a quantity. Whenever you're dividing, you have to keep this as we do whatever's in the denominator first. Okay, so if you want to put parentheses there, you can. Okay, and then I just go across. So x plus 6 does not match anything in the denominator. X minus 2 does, so those divide to make 1. 2 isn't going to divide into anything. And then 1x plus 4 can cancel out with 1x plus 4. So you can't cancel out both of them, but you can cancel out 1. And then again, we're going to leave this in factored form. So we'll have 2 times x plus 6 on the top. We'll have 1x plus 4 on the bottom. Again, the bottom can contain parentheses or not, doesn't matter. This one has to have them because of that 2. Okay, and then for B, when we factored the denominator, we got x plus 4 times x minus 4. Okay, so we keep, we're going to change, and then we're going to flip. So when you flip this one, we're going to put the factors of x squared plus 11x plus 28 on the top. Okay, so that's going to be x and x. 7 times 4 is 28. 7 plus 4 is 11. We have x and x here. Now this is a negative, which lets me know my signs are going to be opposites. So to get a negative 2, that means I want the 3 to be positive and the 5 to be negative. 3 minus 5 is how I get a negative 2 there. Multiplying opposites is what gives you the negative on the end. And then again, I'm just going to start here. So x minus 5 divided by itself cancels out. X plus 7, nope. X plus 4, yep. So then if I go straight across, I'm left with x plus 7 in the numerator. In the denominator, I have x minus 4 times x plus 3. You do need your parentheses on the bottom there. Okay, it looks like many of us do remember how to do this from a previous class, so that's great. Sometimes when we get into ones like these, they can be a little trickier. So like we're factoring here, you have x and x, you have a negative 3, a positive 2, so a positive 3 and a negative 1 is what you would have. Here you have x minus 3 plus 1 to get negative 2. Negative 3 plus 1 is your negative 2. And then 3 minus x and x minus 3 are not the same thing. One thing you can do is you can factor out a negative here. If you do that, the 3 becomes negative, so traditionally we'll put that second, and the x becomes positive, so we'll put that first. And then 3 plus x and x plus 3 are the same thing. So now you're going to have some cancellations here. Okay, so the x minus 3 can now cancel out. Okay, the x minus 1 can't cancel out because this is plus 1. The x plus 3 can cancel. So you can write your answer like this: negative times x minus 1 over x plus 1. So this is one way to write it. The negative 1 is special. So this is the only GCF where you'll be able to have multiple ways to write it. You could also write it as a negative x plus 1 over x plus 1. That's a correct answer. Okay, or you can write it as 1 minus x over x plus 1. That's a correct answer too. So any of those are correct. Okay, if it's a number other than 1 or negative 1, you do have to make sure it stays on the outside. Okay, but the negative 1 can appear in various ways. Okay, do you guys have any questions for me over those? All right, then let's do the last one. So did we recognize that this first one was a difference of two squares? 2y plus 3, 2y minus 3. Okay, and then on the bottom, you have 2y and y. Okay, when you're doing something like this, one thing you can kind of use to help you is you can say, oh, maybe one of these will cancel out. So if you try to put a 3 here and try to put a 6 here, that can help you with this. So it needs to be a positive 9. So if I make this positive, this would be 12 minus 3. 12 minus 3 is 9. Negative 3 times 6 is negative 18. That can help when you're doing the guess and check process. And then again, remember, you're flipping this. So it's y and y for the bottom. You have a positive 6 and a negative 1. That's what's going to add to 5. Okay, for this one, you have 2y and you have y. That's how you start. If it's a negative 3, you're going to have opposite signs. So we can try plus 3 and minus 1. 3 minus 2 is a positive 1. Okay, so make sure you're doing that guess and check. You can just do that part in your head. Remember using 1 slash so we can still see underneath. Sorry. And then in this one, they all canceled out. So what are you left with? 1. Because remember, they're all being divided. So if everything divides out, you're left with 1, not 0. Okay, it's everything divided by itself, and that's why you are left with 1. All right, good work. So that is multiplying and dividing. The next thing we're going to talk about is adding and subtracting. So we have to find a common denominator, and then once we have a common denominator, whatever it is, the rule is the denominator stays the same, and you add the numerators together, okay? Which means we're going to have to be simplifying the numerators here in order to add them, combine like terms. And any common denominator is going to work, but it's going to be less work if you use the LCD or the least common denominator. Okay, so to find that, you want to start by factoring each denominator so that you can see what the factors are, and then we take the product of the distinct factors. And distinct just means that they're unique. They're not the same. Okay, so after you factor, you're going to take the product of those distinct factors. Okay, and in some cases, you're going to have to look at your exponents. So like if you have x squared and you have x cubed, okay, you're going to have to go to the higher power because you aren't going to be multiplying the higher one by a negative. Okay, you always want to multiply to get to the LCD. Okay, so you have to use the highest power that appears in each denominator. Okay, all right, so we have 5 over x minus 1 plus x over x plus 3. Okay, so these are already factored. So your LCD has to have x minus 1 in it, and it has to have x plus 3 in it. So to get those, we're going to multiply. So I'm just going to write this again so you can see what we're going to multiply by. And remember, when you have expressions, you have to multiply by something equivalent to 1. So I can multiply by x plus 3 over itself because I'm not changing the value. Anything over itself is equivalent to 1. Okay, so I'm not changing the value here. Now this is where sometimes people get confused because we are kind of going back and forth between a few different things here. So you are going to distribute in the numerator. So we're going to have 5x plus 15 over x plus 3 times x minus 1. And then for this one, we have x squared minus x. Okay, and now we have a common denominator. So we can combine all of our like terms. Okay, so in the numerator, I am going to combine my like terms together. So I have x squared, I have 5x minus x, which is going to give me 4x, and then I have 15, and that's all over x plus 3 times x minus 1. Doesn't matter what order you write them in. Okay, you do want to see if that is factorable. But because these are both plus, right, if it's 15, the lowest factors are 3 and 5, and no matter what, that's going to make 8. Okay, so this is going to be your final answer because that is not factorable. Okay, sometimes it might be, other times it won't be. Okay, and then we're still just keeping these in factored form. Okay, so you don't have to multiply those out again. Okay, so you are simplifying your numerator there. Okay, you need to do that. Okay, for B we have 2x minus 1 over x plus 4 minus 1. Okay, so I want you to think about what your LCD is. Oh, yes. Okay, so our LCD is just going to be the only denominator we have, which is x plus 4. Okay, so anytime it's a whole number, that's over 1. So we can multiply that by x plus 4 over itself. Now this is where you want to be careful because you have 2x minus 1, and then this is a negative 1 times x plus 4. So you have to make sure you distribute this negative. Okay, you have to distribute that to both. So we have 2x minus 1 minus 1x, or minus x, minus 4. And then we're going to get our like terms together. So 2x minus x is x. Negative 1 minus 4 is negative 5. And then this will be your final answer. X minus 5 over x plus 4. Okay, any questions for me on getting the common denominator? All right, let's go to fractions within fractions. So a compound fraction has fractional expressions in the numerator, denominator, or both. Okay, so I just call them fractions within fractions. And again, we're going to leave these in factored form. Okay, so for the first one, we have u over v plus 1 divided by v over u minus 1. So I make my u's like with the little curl on there to help. Okay, so sometimes it's overwhelming if you look at the whole thing. What I try to do is just simplify each one. So the goal is to simplify the numerator to one term. Okay, if we can simplify that to one term, and if we can simplify the denominator to one term, then we can skip, flip, and multiply, or sorry, keep, change, and flip. Okay, so that is going to be our goal. Okay, so if I'm just looking at the numerator, my LCD is going to be v. Okay, so all I have to do is multiply this by v over v. Okay, so if I do that, then I have u plus v divided by v. Right, if I do v over v, u plus v divided by v. Okay, and then we're going to simplify the denominator. Am I going too fast, or is this okay? All right, so then the LCD is going to be a u. So you multiply by u over u. So then I have v minus u divided by u. Okay, and then once you have that, like we said, keep, change, flip. So u plus v over v is going to stay the same. I'm going to change division to multiplication, and then I'm going to flip that bottom fraction. Okay, sometimes you might get something that cancels out here, other times you won't. And if nothing cancels out, you're just going to multiply straight across and keep it in factored form. So this is u times u plus v over v times v minus u, and that is how you're going to leave your final answer. Okay, so you're going to leave it in factored form so you don't have to distribute there. Okay, you can leave it just like that. Do you guys remember doing some of these before? Okay, let's give this one a try. And again, we're just going to simplify the numerator first, then the denominator. That's going to be C minus 2 over C minus 1. And then I'm ready to keep, change, flip. So keep, change, flip. Okay, so in this case, I have the C minus 1 divided by C minus 1. I can cancel those out. And that's going to leave me with C over C minus 2. Okay, and that is going to be my final answer. Okay, how did you guys do on that one? Doing good? All right, we'll kick it up a notch for part C. So we have x minus 3 over x minus 4 minus x plus 2 over x plus 1. And then all of that is divided by x plus 3. Okay, so why don't we start picking out what we're going to multiply by for the top. So I want you to write that out. What are you going to multiply each value by? And then this one is a little bit trickier. Okay, so once I know what the LCD is, I just will write that here, x plus 1, x minus 4, because I know I'm going to be combining those. Okay, and then what I have here is x minus 1 times x minus 3. Please do not start canceling things out. Do not cancel this out with this. You can't do that because this is a minus here. Plus, if you start canceling some of these things out, then you aren't going to have a common denominator anymore. You cancel this out, then this denominator is x plus 1. This one is x plus 1 times x minus 4. You can't combine across the top anymore. So the whole reason why you're multiplying is to get that common denominator. So what we're going to do is we're going to FOIL. Okay, and then we are going to FOIL these. So when you FOIL, you want to put that in parentheses. If that helps you visually, you can. Okay, x times x is x squared. 1x minus 3 is negative 2x. 1 times negative 3 is negative 3. Now, because you have the minus here, make sure you put the minus, and then I'm going to put everything behind it in parentheses so I don't forget to distribute that. Okay, so I'm going to FOIL. I'm going to get x squared plus 2x minus 4x, which is negative 2x. Okay, and then negative 8, and then I'm going to distribute. If you change this to a plus and you make that a negative and then FOIL, that would be another way that you could do that. So I have x squared minus 2x minus 3 minus x squared plus 2x plus 8 is what I have. And then this whole time, this is all over x plus 3. So that is still hanging out there. Okay, and then I can get my like terms together. So x squared minus x squared, those are actually going to cancel each other out. Same thing with negative 2x and 2x. So the only thing I'm going to be combining is a positive 8 and a negative 3. So I have 5 over x plus 1 times x minus 4. And then that whole thing is divided by x plus 3. Okay, and I'm writing this out in 2 steps. Technically, when you're doing this, you could just multiply by the reciprocal. I recommend doing that just to save some time. So when you skip, flip, and multiply, think about what this is, right? When you keep, change, and flip, this is over 1. So when you do the flip, the x plus 3 ends up in the denominator, okay? Or think about multiplying by the reciprocal, you're going to put that 1 over it, okay? So then your final answer is going to be 5 over x plus 1 times x minus 4 times x plus 3. Okay, and that is going to be your final answer. Okay, what questions do you guys have on that? Feeling good? Remembering some things? If it's a GCF, yes. Yeah. And really, like, you're not going to want to FOIL all that back.